Okay, good afternoon, good morning, good evening, wherever you are. This is Julianne. I'm with ProSoft, and I'm so glad that you joined us to our demo, Designing an Industrial Wireless Network. A few things before we start. We encourage you to post questions in the Q&A box during our session, and we'd be happy to get to those at the end. And also, we're going to share this presentation with you along with a copy of the recording. So I'd like to go ahead and introduce Brian Allport. He's our global business development with focus on wireless. So go ahead, Brian, take it away.
Great, thank you. So we have a really nice and quick presentation here that outlines some of the key features and benefits of our free wireless network planning tool that's available online on our website. It's called PWD, ProSoft Wireless Designer. And with us is Friedrich, our product manager. He's going to go through this. He's going to give us some key considerations we need to think about when starting to design a wireless deployment. And then he's going to show a quick demo at the end illustrating how easy it is for all of you to support your customers or to support your own deployments with wireless ProSoft products. But before all of this, I'd like to center ourselves around the wireless technologies that ProSoft has to offer so we know exactly what we can use this tool for. So right here, you can see we have 3 different purpose-built, hardened, and industrial-focused wireless portfolios. We have wireless LAN or wireless Ethernet. This is our RLX2 product family, and it's ideal for real-time data transmission for control systems. We'll talk a little more about this soon, but first we can also see that we have a wireless remote access and a wireless persistent data network offering. So both of these applications leverage our ICX35 cellular modem, where secure remote access is perfect for remotely troubleshooting, servicing, or commissioning equipment, and the persistent data network is ideal for interconnecting multiple remote sites, whether they're in the same county, different counties, different states, or even different countries. So these are all the really great technologies we have here that we can use PWD to lay out the network, generate a bill of materials for both wireless Ethernet or cellular technologies. So focusing on this PWD tool, let's keep in mind the types of applications that we can use this tool with. So this next slide right here, focusing on wireless LAN, we can see that we have 2 different types of applications that we focus on. The first is the traditional stationary application where the access points and the clients are all fixed. So wireless is used to connect the controllers or to pull remote IO into a PLC or to simply extend a network and enable a mobile worker to connect to their equipment without having to physically plug in. On the right, we have a mobile application. So this is where you may have mobile robots, AGVs, cranes, or other pieces of mobile automation that need to maintain connectivity to a main controller somewhere. Our radios are perfect for these applications. We actually have a lot of special features built in, like ultra-fast roaming, that allow our radios to maintain connectivity through the entire path of travel for that robot without dropping packets. This enables a ton of next-generation applications for our customers. And it does require a certain level of expertise, a ProSoft level of expertise to engineer a successful application. So here we could use PWD to generate a bill of materials, but it's critical to engage our field application support team. They specialize in these applications and how to ensure success. And we can talk a little bit about that soon. Next, we can jump into cellular. So we mentioned secure remote access. We mentioned persistent data network. From a network design perspective, from a hardware bill of materials perspective, PWD really gives you everything that you need. Cellular gateway, any extension cables you may need, the appropriate antenna for LTE connectivity. The tool ensures that all of the connectors throughout the whole system are compatible, stuff like that. Beyond that, our system, built on ProSoft Connect, our SRA, our PDN, really handles the rest. So when thinking about the best application or use cases for these types of technologies, secure remote access, as most of you know, is perfect for remoting into an industrial system. Beyond our security features like our tunnel architecture, IP waitlisting, we have a really unique feature called vLotto, or virtual lockout tag out. vLotto gives the administrator for the system, which is typically the end customer, complete control in real time, digitally, and that control controls who remotes in, how long they're in for, and what equipment they have access to. So that's all critical in those types of applications with SRA. Focused on PDN, or the persistent data network, we have the same security features as SRA. We can think of this as a layer 2 switch in the cloud, an always on connection of remote devices. This is an easy drop-in replacement for the antiquated long-distance frequency hopping applications, or really a true future-focused IIoT enabler, giving you or giving your customer the connectivity they need for real-time visibility into key metrics of their application, wherever in the world it may be. So we have wireless Ethernet, we have cellular, and we have these really cool applications on ProSoft Connect, which enable us to solve a lot of different connectivity challenges for our customers. Partners, customer, and application success are important to us. So this last slide here shows some of the service and support offerings that ProSoft has available to help enable the success across the board. So of course, we have this free software tool. We're about to jump into it with Friedrich, but we also have an incredible wireless field application support team. In general, these guys can help with anything you need from a wireless perspective. Proactive system design, engineering drawing reviews, site surveys, reactive physical inspections, or troubleshooting support. Anything you need, we're here to help. So keep this in mind. Friedrich, let's jump into PWD.
Thanks, Brian. Hi, everybody. My name is Friedrich Hausmann. I'm the product manager for products in ProSoft and coming from Berlin. I would like to present to you a little bit of a new kind of way of looking at wireless. I know wireless always seems to scare people a little bit. They think it's difficult, but I want to show you today in one example. We're going through a water treatment plant, how easy it is to get started, to get confident in, and how to get your feet wet. With our ProSoft Wireless Designer, I think you can easily see at the end of this presentation that it's not too difficult to actually plan a small wireless network yourself. And the tool also provides you everything that you can send to us to verify that the tool, that your setup and network is working correctly. And at the end, we can give you guidance and assistance through our field application tuning. So what we see here is just a couple of example slides, how these water treatment plants look like. Basically, I just like to use it as an example. You can pick one in your local area, just open up your favorite maps tool and find one in your area. It's nice because then you can identify the need for it. In these water treatment plants, we have a need for communication and sometimes wireless communication, because these water treatment basins that you see, they have rotating parts, meaning putting any kind of cable in will be difficult. So for example, when you want to have your PLC or your video camera or any kind of sensor mounted here on the mobile part, you might want to connect it and be able to access it from your control room. And that's something we're going to look at today. It's just an entry. I hope it's fun for you. We're going to go through a little bit of theory first, and then at the end, I'll do the live presentation of the software that you got familiar through the theory part. If you have any questions along the way, just like mentioned before, ask us right away. Some of them I might be answer immediately. Otherwise, it will be at the end of the session. Okay. So I took one of these water treatment plants from a free maps service. I just illustrated we're going to do a setup of 2 Wi-Fi cameras here in 2 of these basins. And we're going to make the connection, a wireless Wi-Fi connection to the control room. Control room would then be able to see a live feed of the cameras, as well as maybe some PLC data for control coming in, meaning they can attenuate the speed, or for example, they could check the water temperature, the water quality, everything remotely connected, even though it's on a moving part of the facility. With the ProSoft Wireless Designer, we're going to do a simple setup. I'm going to show it to you live at the end. But the key points here are, for example, we're going to mount the antennas at 10 feet height. So this would be represented here. We're gonna use our product RLX2, which uses the G band, meaning it's 2.4 gigahertz. If you never heard about it, basically, if you want to get started to do an auto application, use the G band. It has a lot of range, it has lots of output power. And the -A means just it's for North America. But the tool itself will also recommend you our other products for other regions of the world. The locations I entered here are actually taken from a water treatment facility in the USA, but you can find your own water treatment plant in your area or any other kind of outdoor facility that you want to play around with. The tool is free to use and download, and I hope you get motivated to give it a try at the end of this webinar. Okay, now for the difficult part, but I promise you it's not going to get more difficult than 1 plus, 1 times minus, and that's the whole range of math we're going to go through today. So for illustration, when you set up a wireless link, so this is our device, and it has a cable, long cable to an antenna, for example, which is mounted at the top of a mast. In this example, we're going to mount the device at 5-foot height, so you can easily reach it for maintenance. And then we're going to attach a 10 feet long cable until the top of the mast. The top of the mast then has the antenna placed and makes the connection to exactly the same setup on the other side. I just wanted to keep it simple to get everybody started here. So on the other side, we have the antenna at the top of the mast, we have the 10-foot cable, we have the device mounted at chest height, 5 feet roughly, and then this is down to the ground. So now when you're thinking about Wi-Fi in this example, Wi-Fi, the only thing you need to know that it's a little bit different than a laser. If you imagine you had a laser pointer at the top of the mast and you were shooting it straight away to the other antenna, then everybody would understand if there's any obstacle in between, like a building, and the laser cannot get through, then the connection would not be able to get through. Wi-Fi is similar, but it has a little bit wider range. So we need to consider something called the Fresnel Zone, which is kind of an elliptic curve between the two antennas. So instead of imagining just a straight line with the laser from one point to the other, we kind of need to think of it, the waves for communication need a bigger space. They need a little bit space above the direct line in either way. In three-dimensional space, it's basically a big volume of extra space necessary for optimal communication. What we then need to know is how much do we need to calculate? Like, is it okay to have a small bush in the middle or a building? How high do we need to go with the antennas? And for that, it's easy in our software. It just gives you the measurement already. So when you set up the links with the outdoor coordinates, it will tell you the Fresnel zone is, for example, here 6.2 feet, which means from the antenna height, which is 15 feet high, so this is the calculation here, 5 feet chest height plus 10 feet antenna cable height. We're going to subtract down the 6.2 feet of Fresnel zone, which then gives us a clearance below the first Fresnel zone to the ground of 8.8 feet. So meaning any obstacle which is smaller than 8.8 feet is not going to impact the communication. Any obstacle, like a big tree or, for example, a building in between, which is higher than 8.8 feet, will impact the communication between these two antennas. So that's a very basic understanding. When you design a setup like this, just watch out for any obstacles in between. To solve this issue, either you find a different path, meaning you put another device in the middle, which you're going to explain later, or you, for example, make the antenna mast higher. So instead of 10 feet, maybe make it 15 feet high. Okay, and then in detail. So these two cameras are the ones we want to connect to. Along them, next to them, we're going to mount 2 of our ProSoft wireless devices, and we're going to set up a connection to a repeater. A repeater is necessary because in the slide before, when you see here for the 2 cameras, they don't have direct connection to the control room up here. There are some buildings in between. So what we're going to do is in the slides, in the next slides, is set up a repeater along the way here. A repeater basically takes the signal from one of these clients. They send it to the repeater, which then is able to send it to the control room because it has a clear Fresnel zone in between the setup. So the final setup looks like this. On the right side, you see it overlain on the map. So we have our two devices, clients down here. We have one repeater in the middle, and then a free path down to the control room. The setup in the wireless ProSoft Wireless Designer software then looks like this. So we have BASIN second row, first one. We have BASIN second row, second one, which are these two here. They connect to the repeater. The repeater, you see, has two connections down and one connection up. So the tool gives you a recommendation how strong the signal will be. For those of you who know Wi-Fi, they know minus 60 dBm is a good signal. As long as it's good or very good in a ProSoft Wireless Designer, it should be okay. What you need to consider is you don't want to go too low. So there are different levels. Connection quality, medium or poor, for example, would then be represented by the colors orange or red. When you already have, from the theory, a poor connection, then you're going to run into trouble when, for example, the next storm comes, when some heavy snow is falling down, when there's a heavy rain. You don't have enough buffer to keep the connection alive. So always try to aim for the best connection possible, to have some reserve for difficult environmental times. You see the distances in between these connections. So 0.08 miles, that's the distance between the repeater and the BASIN 1. And 0.1 miles is the connection length between the repeater and the BASIN 2. The network speed we're going to aim for here is a simple 50 megabit speed. 50 megabit, if you imagine each camera, for example, a normal surveillance camera has 1 megabit connection speed. If you're gonna go for HD quality, that's maybe 3 to 5 megabits. So we have enough room here for the video cameras. Of course, any sensor or PLC you run on it additionally is not gonna impact the bandwidth calculation because they usually need very little data. They just need have it delivered reliably. And then at the end, the software also gives you a complete list of the tools you need. I'm not gonna go into too much detail here, but Wi-Fi is a little bit more than just an antenna and a device and a cable in between that you need to know about, and that this tool will automatically list for you. So you can have the complete list for your project. You can send it to our support and engineering team for verification and get a full quote on it. So what list and what parts are part of this solution? The first one is the device I already explained to you. It's our Wi-Fi device. It's operating in the G band and it's for North America. If you select in the tool Europe or any other country, it will give you a recommendation for the correct device. Then we need to have a cable. This device needs to be mounted inside a chassis to protect it from the environmental impact. We need to have a small cable to the chassis, which then goes into something very important, a lightning protection. Lightning protection has two functions. For once, first function is to protect actually against lightning, meaning any cable in the chassis, nobody should have a direct connection to the top of the antenna. There always needs to be a lightning protection in between. Otherwise, it's a very, very bad setup. So get in contact with your power consultant. He will know what to do with this lightning protection, but basically it's just a resistor that shuts off in case of a high surge pulse, cuts off the connection between the antenna and the device to protect the device, but also more importantly, people. Then we have the cable going up to the antenna. This was the 10 feet I mentioned before. We have the mount, the antenna itself, and then we have one roll of duct tape, which is used to insulate a special outdoor duct tape, which is UV resistant, insulates against any water coming in of any of these connections. Okay, Now we're gonna do the live demo and the questions. I'm gonna do basically the same setup I just showed you step by step. If you have questions along the way, feel free to ask. Okay. Just a second here. So that's basically how the software looks like. I think you should be able to see it now. The first thing we're gonna do is set up the project. So what we have here is a water treatment plant. And this is obviously an outdoor application. If you want to help assistance with indoor applications, like for example, AGVs, robots, that kind of thing, then you could select indoors here and you would get similar recommendations, just a different kind of setup. Okay, so what do we want to do? You can either click Help Me Decide, which will guide you through what kind of technology you need. But in this demo, we went with 802.11, which is Wi-Fi infrastructure. Benefit here is we have higher speeds up to 300 megabit. And as I showed you, we're going to use the device IHG-A, IHG meaning it's 2.4 gigahertz. And -A means it's for the North American market. So here you can select the region. If you select Latin America, Asia Pacific, it will give you a warning if you selected the correct device or not. In this case, North America is already the correct selection. Okay, now the project is set up and we are gonna enter the different locations. So first location would be the control room. Distance antenna in feet. You remember the antenna is mounted at a total of 15 feet height, but we are only counting the distance to the antenna from the device to the antenna itself, meaning the device is mounted at 5 feet chest height, and then an additional 10 feet are coming on top. If you want, you can use a mixture of different radio devices in your setup when it gets more complex, but we're gonna keep just one device setup. If you want, you can, if it's an outdoor project, like here, we're gonna enter the coordinates from the GPS coordinates directly. But you could also, of course, just enter the distance of the connections in between yourself in feet. So I'm just gonna check the coordinates available in all the mapping services like Google Maps, Bing Maps, or any other you find. I wanted to show it to you live. There's one which has free GPS data globally, but it's currently down for maintenance and will be up just at the end of this webinar. I'm going to show it to you later, maybe for your own use and demonstrations, it might be useful. So what I entered here is just the latitude and longitude of the first connection. We're going to set OK. And we already have our first control room set up. Now we don't need to go through all the settings again, but I want to change one thing. I just do a double click. And you see by default, we have a strong patch antenna selected. Antenna is a symbolic reference here, which is then connected through a cable with the lightning surge protector with another small cable like we went through before to the device itself. And what I want to change is the antenna. By default, it's this panel antenna, which is very strong, which might be good, for example, for a simple point-to-point connection, just connecting two ranges. But if you have a setup with multiple devices, you need a less pointed connection. So I'm gonna just pick one of the antennas here. A stands for antenna. 2.4 means 2.4 gigahertz, which is the frequency we use, and I would recommend for simple outdoor installations. And then the 0.9 is basically a 9 dBi antenna, meaning this is how strong the antenna amplifies the signal. 9 dBi is a good mixture between sending the data everywhere and focusing it too high just for a simple point-to-point connection. And that's basically it for that was the most difficult part of the setup. Now what I'm going to do next, I explained to you before, we're going to set up the repeater. And for that, we can just use the copy function. We paste it. Visually, it doesn't matter where you put it here because the distances are calculated with the latitude and longitude. So this is our repeater setup. Now we're going to change the location. Feel free to explore your own project if you give it a try with your own maps. Just a second, I'll copy them over. That's the latitude. If you want to follow along in the recording later, you can do so as well, and you can check it out on your own maps. Okay. Now we set up the repeater side, and now what in order to get the information how good or bad is the connection, we're just gonna drag and drop the connection here. And now we see I made a mistake. Somehow we have 6,000 miles. So I need to quickly double check the locations of these devices. Maybe we can, one of my colleagues can see if we have any questions in the chat while I do that.
We do have a question in the chat. Looks like one of them was answered. Brian, do you want to, or maybe you're answering another one.
Yeah, we can talk about them both. So the first question was, should a spare lightning protector be sold with every project? Because it sounds like a consumable fuse. And the answer is that SPDs in general are consumable, but are engineered to handle several events. So in the typical application, one for the lifetime is no problem. But if you're in a high problem area like Florida, for example, where there's lightning strikes frequently, big metal towers, possibly a water wastewater application, yeah, there would need to be a different set of things to look at from a surge protection standpoint, and there it definitely would make sense to have several on hand to replace them. As you know, different towers are getting struck. The second question I'm in the process of answering, how would this process look different for a plant floor application which may have metal items in between the antennas? So this is the perfect example of where we could have our field wireless application engineers come in, help review the drawings of the environment, the layout of the plant, and potentially, depending on the type of application, conduct site surveys. So we, inside plants, do a lot of business in the automotive industry, for example. So our field application engineers spend a lot of time in those plants before the deployment of the mobile automation in those plants, and during and after, to do these site surveys, make sure these antennas have line of sight. That is a requirement. The antennas must have line of sight, and they can help engineer the system in a way that makes sense for that application to ensure that we've got the connectivity required. Two good questions, though.
Okay, thanks for that. I think I have just found a mistake. I made a mistake in doing the copy and paste, I think because my German computer language setup interferes with the comma and the dot, just like everywhere. So what I did, I set up the repeater connection. I fixed that part in the meantime. And then I'm just going to do the basins. Just a second, we should be there. Okay. So the first connection is already green. I set it up correctly. Now we're just going to have to figure out where I did the copy and paste mistake of the location. So that would be 39. Okay, I don't know what I did wrong here. So let's check it again. Ah, okay. I think somebody in the chat helped me along. Ah, okay, there was the mistake. Thank you so much. And we're gonna set up the wireless connection here. Nope, still the mistake there. Okay, but at least we got one connection, right? What I did here, that's our repeater setup. We use the latitude and longitude. We copy that one from the maps. You see here, just because we used the copy and paste, we already have the correct antenna setup. It's symmetrical, both on the same sides. So for a very simple project, you get this information here. If you click on the link connectivity, you see the Fresnel Zone, 6.3 feet, just like in our example theory before. You see the signal level is here excellent. Of course, the signal level goes down the longer the range is, the more interference you have along the way. This is the theoretical maximum. It would be advisable to stay on the good or excellent level for auto applications. So then at least you have a level of 10 dB here reserved for bad weather conditions. If you're already at the limit, for example, your connection is down at poor quality or broken quality, maybe your application doesn't need the full speed. So instead of going with 54 megabit, maybe for your application, 11 megabit is enough. And that changes in case the connection was poor before, we'll change it to a good value or similar. Okay, and that concludes the live part of the presentation. Are there any more questions? Then thank you so much for your time and attendance. I hope you had some fun. You see, getting the foot and getting the hang of Wi-Fi is not so difficult with our free tool. You can get started with simple outdoor practice installations. Of course, when it comes to more difficult setups, like our favorite setups, like Brian mentioned, AGVs in a factory, they're gonna need a little bit more experience and hands-on, but feel free to get started in your factory environment, send it to us and we'll look it over. We got a question, what tools would we recommend for validation of the bandwidth? So the devices itself show you the link once it's up and running, but maybe what the question is about is how do we test it? And for testing, there are many free tools. It starts with a simple ping. The ping is there comes in various forms and sizes. Most operating systems come with it automatically. You can also download visual tools of that kind to check if the end-to-end connection is there. So in fact, you're gonna check, for example, can you reach the camera or not? Then for bandwidth testing, the simplest one is something called Iperf, I-P-E-R-F. That one can be installed on 2 laptops. One would be in the control room, one would be outside, attached directly to the device in the basin, and you can do a full bandwidth test. It will show you how many megabits of throughput you can achieve. And maybe to answer that with these are the bandwidth estimations. So here we have a bandwidth estimation of 54 megabit. That is between basin 2 and the repeater. And we have the same from basin 1 and the repeater, and the same from the control room and the repeater. But if you have to think about the whole application. So for example, if we use 10 megabit from basin 1, so that 10 megabit will be transferred along this line, and then needs to be transferred along this line as well. So from our 54 megabit here, we are already down to 44 megabit. And here also from 54, we're down to 44 megabit. Now, if we have another camera on the basin 2, is another 10 megabit. So from this line, the maximum bandwidth would go down from 54 to 44. And then from the repeater along this line, because of our first camera, we're already at 44 megabit. Now we added the second camera, now we are down to 34 megabit. So you need to think about the complete application. Okay, thank you so much. I hope you had fun. Talk to you soon.